In Auvergne, central France, lies an exceptional UNESCO World Heritage Site. A series of volcanoes as far as the eye can see, across a tranquil landscape. And yet, the monsters are only sleeping.
We suspect that there is still magma underneath, so the whole chain is dormant.
It's completely possible that a volcano could rear its head at any moment.
It may surprise us and pop up anywhere.
The next eruption could be in 6 months, 10 years, or 1,000 years.
The powerful volcanoes of the Chaîne de Puys region have shaken the region far and wide.
There was a surge that carbonized everything on the Chaîne de Puys. Fragments were found in lakes as far as Switzerland.
While only a few of the volcanoes exploded so violently, most spewed torrents of white-hot lava.
The lava flow spread more than 15 kilometers.
In some places, it could be 100 meters thick. We're talking something really impressive.
The fiery spectacle may be gearing up for an encore. Eruptions could flare anywhere along the Chaîne de Puys, possibly devastating the largest neighboring city, Clermont Ferrand, population 143,000.
I doubt most people in Clermont Ferrand know they live over a volcano. Can you imagine a new crater opening up in that spot in the center of Clermont Ferrand?
A lab in the heart of the city studies volcanoes around the world. But it keeps a watchful eye on its dormant neighbor.
The first thing happened months or even years before. So normally you get a lot of time, but sometimes there's no warning.
What would happen if France's youngest volcanoes angrily shook themselves awake? What kind of eruptions could be possible? And how would it impact the people living here? Despite the state-of-the-art science, could a volcano catch us by surprise? Through expert accounts and 3D imagery, we'll explore these fierce and fiery structures from the moment of birth to the present day. Come discover one of the world's most fascinating natural wonders, the Chaîne de Puys. In the heart of France, some 350 kilometers south of Paris, lies the Chaîne de Puys, a territory that's 40 kilometers long and 5 kilometers wide. Volcanoes as far as the eye can see, harmless, or so it would appear. The Chaîne de Puys has known hundreds of eruptions over a period of 90,000 years. And this dormant range is directly adjacent to the city of Clermont Ferrand. Practically in the city center stands the Puy de Côme, almost 1,500 meters high. This emblematic summit is surrounded by dozens of volcanic edifices.
From north to south, over 35 or 40 kilometers, there are 80, 85, 90 volcanoes. We don't know, because some are underground. When activity began in the Chaîne de Puys, a volcano suddenly appeared. That volcano was active for a few days, weeks, months, and then after a few hundred years, a new volcano appeared. And so from 90,000 to 7,000 BC, new volcanoes started cropping up all over the place. And that's what created this absolutely exceptional site that is the Chaîne de Puys.
Exceptional, but also dangerous. Yet for centuries, no one really understood the telluric forces hidden beneath these summits. Everyone thought they were simply small, peaceful mountains.
I think the populations forgot about the volcanism because the last eruption was long ago, some 6,700 years ago.
These volcanoes are part of the local landscape. The people always lived among them. Back then, there wasn't a lot of movement. So for someone who had never seen a volcano erupt, or even see a volcano at all, these were just simple hills.
Thousands of years have passed since the last eruption. From the first mosses to the first trees, over time the vegetation reclaimed everything and erased the lunar aspect generally associated with this type of landscape. This was a simple process, as the Chaîne de Puys volcanoes only had one primary eruption. That made it easy to hide the threat underground. It wasn't until the 18th century, when a scientist visited the small town of Volvic, that the Puys were discovered to be volcanoes indeed.
It only happened in the 18th century, when French mineralogist Bruthard conducted geological surveys. As soon as he saw the Volvic rock, he immediately knew it was lava and classified the Puy de Côme as a volcano.
What we didn't know back then was that this volcanic chain was ready to spew out lava and volcanic bombs again at any moment. The region's youngest volcanoes erupted less than 10,000 years ago. And that's how scientists know that this chain is not extinct. It's simply dormant.
A volcano is considered to be active when it's had at least one eruption in the last 10,000 years. And in the Chaîne de Puys, there have been many eruptions in the past 10,000 years. 10,000 years may seem like a lot, but for Earth, it's barely a blip. But even that isn't exact, because in 2006 there was an eruption at an Alaskan volcano after 14,000 years of dormancy.
We know that most volcanoes there are extinct individually, but we suspect that there is still magma underneath, so the whole chain is dormant and may erupt again at any time.
The next eruption could be in 6 months, 10 years, 1,000 years, or even in 3,000 years. We just don't know when the next eruption will happen.
And we don't know where either. Although we know it won't be beneath the ancient craters.
The Puy de Côme won't reactivate. If the Chaîne de Puys reactivates, it will be through a new volcano.
Why a new volcano? To visualize it, one simply needs to go to the north side of the Chaîne de Puys, at the L'Homme de Gis volcano, an old volcanic rock extraction quarry. In the heart of the old crater, one can still see the conduits through which the magma welled up and hardened. After the eruption, they completely crystallized as a hard plug that blocked additional magma. The same thing happened to every volcano in the Chaîne de Puys.
When the magma moves towards the surface, it won't try to flow through a pathway that's already so hard. It will find a weak spot in the Earth's crust through which to reach the surface within the Chaîne de Puys, somewhere a few hundred meters or a few kilometers from the previous eruption site.
Far more likely it would be where the more recent eruptions have happened, like at Lac Pavin, Puy de la Vache, but it may surprise us and pop up anywhere.
One of the sectors that could reactivate is an area located about 20 kilometers south of the Chaîne de Puys. Lac Pavin. That's where mainland France's youngest volcano is located. This volcanic zone could potentially be one of the lightest sleepers. How was this lake formed? Why does it have 2 layers of water that don't intermix? And what dangers lurk in its depths? In overcast weather, its waters are a deep black. It's been called the Devil's Lake. It's a place of many mysteries and legends.
One common legend is the myth of the sunken city. And to top it off, it's rumored that when you take a boat out on the lake, if you listen closely, you can hear the church bells of the sunken city.
There are legends about the lake, which is said to have its own putrid clouds that smell like sulfur.
Perhaps some of these myths are due to the lake's volcanic nature. Because Lac Pavin was actually created by an eruption some 6,700 years ago.
At Lac Pavin, it was magma that rose up. The magma rose towards the surface of the earth and hit a water table. Everything on top was torn away, which was actually the Puy de Monchal lava flows that had only emerged a short time earlier.
That's what's known as a phreatomagmatic eruption. The water vaporizes, and there's an instant explosion. The lid blows off. The lava comes out, and the lid is shattered into many small fragments, which then fall back down and create a beautiful Mare crater that's usually round or oval-shaped.
The crater is roughly 800 meters in diameter and about 92 meters deep, and the hole was filled with water. It was partially filled with rainwater that fell inside. And at the bottom of the lake, there's a mineral water source, which makes it a little salty and bubbly.
Moving beyond the myths and legends, mainland France's youngest volcano hides other secrets within its waters. Some of them are potentially dangerous. That's because Lac Pavin is one of our planet's rare lakes where the waters do not intermix. A meromictic lake.
Lac Pavin is made up of two lakes. There's the upper part, roughly 55 to 60 meters, which is a normal lake in contact with the atmosphere. Then, beneath that, there's water that's completely deprived of oxygen. Any fish that swims there won't have enough air. At the bottom, there's a layer that's very cold and with little light. It doesn't mix with the waters above because the volcano is surrounded by a tall relief that prevents the wind from stirring up the waters. So it's a very particular kind of aquatic environment.
The deepest part of the lake will never rise up, and gases can accumulate within that layer.
And what if Lac Pavin freed the gases from within its deepest layer? One of those gases is deadly, invisible, and odorless. Carbon dioxide. That very gas was responsible for a terrible disaster that took place in 1986 in Cameroon at Lake Nyos, a volcanic lake just like Pavin.
The whole area of that part of Cameroon is very volcanic, and like in the Auvergne, there's a lot of carbon dioxide coming up, which was trapped at the bottom of the lake, and something caused that to change. We don't really know what happened exactly.
Some 30 years later, we still don't know exactly what triggered it, but one of the most credible theories is that it was triggered by a landslide. A large quantity of soil could have suddenly fallen into the lake, causing the layers to mix and freeing the carbon dioxide that had been trapped at the bottom.
There was this wave of carbon dioxide, a very dense gas, denser than air, which was expulsed. But it was totally imperceptible to the local people. It flowed down into the valleys and killed 1,700 people, along with a large quantity of cattle, birds, and insects.
After that, the government tasked us with studying Lac Pavin to determine whether there was a similar risk. It turns out there isn't. The carbon dioxide levels at Lac Pavin are much lower than at Lake Nyos.
The risk is apparently low. For now, the only gas rising to the surface is that of divers training in Pavin. Yet the lake is still being monitored by scientists because its levels of carbon dioxide change over time due to microorganisms present at the bottom.
We know there's gas at the bottom. We can see it when you stir up the bottom. Bubbles come up. The question is there a lot or only a little? We don't know.
Even if a degassing of Lac Pavin is highly unlikely, what are the chances of a new eruption that would create a volcanic Mare crater?
The chances of a new Mare crater being created in the Chaîne de Puys are real because the chain has an abundance of water. We can see that along the Chaîne de Puys, there are clouds that form directly above the volcanoes. They provide rain, which is then entirely collected.
The water's always there. All you need is the magma.
magma that could not only emerge in the Chaîne de Puys, but also in the neighboring plain, which is also water-rich, the Limagne. What's worse, that magma could emerge in a particularly sensitive area, the center of Clermont Ferrand. The city is built over a risky area, right on top of an old volcano. It's buried directly beneath this square, named Place de Jaude.
It was what we call phreatomagmatic, which is phreato, water, and magma mixed together. So in the area of Clermont Ferrand, we're in the Limagne basin, just full of water. So the magma came up, met that water plus something very, very hot, it goes bang.
The crater left by the explosion transformed into a lake. Then it was slowly filled, both by sediment and by lava flows from other volcanoes. It became a swamp, which was later dried out in order to build the city. Clermont Ferrand was erected on top of this geological scar, all without the population knowing what dangers still lurked beneath their feet.
I doubt most people in Clermont Ferrand know they live over a volcano. There's a mound that's topped with Clermont Cathedral. It's very easy to see, because it's built on the volcano's ring of ash.
A large ring and crater that are big enough to cover the equivalent of 5 Eiffel Towers lying down.
You have to remember that this eruption created a crater that's 1,600 meters in diameter. That's no laughing matter at all. I mean, can you imagine a crater possibly opening up near that same spot today, in the heart of Clermont Ferrand?
Clermont Ferrand, the Chaîne de Puys, or further south at Lac Pavant. There are multiple locations for a potential eruption, because this region has a vast number of volcanic features. Why is there such an intense concentration of volcanoes in such a small area? Why do they have different shapes? And why are some more threatening than others? To understand, we have to go back 25 million years to the formation of the first volcanoes in Auvergne. Several phases of eruptions succeeded one another in the area, but the biggest, most spectacular eruptions took place in the department of Cantal.
Large volcanic massives were created south of Auvergne, including the enormous Mounts of Cantal, a large stratovolcano stretching over about 2,700 square kilometers. That's double Mount Etna. That volcano was 3,500 to 4,000 meters in altitude and collapsed on itself.
If such volcanoes appeared in Auvergne, it's due to a very long process that's invisible over a human lifetime. These extreme phenomena happen beneath the Earth's crust, which protects us from them.
The best image we can use to represent the Earth is an avocado, a spherical avocado. If you cut open a spherical avocado, the skin corresponds to the Earth's rigid plates. There's about 30 kilometers of continental crust and an oceanic crust that's 5 to 6 kilometers thick.
Beneath that crust, temperatures already reach 2,000 degrees Celsius. That's what's known as the mantle, a viscous fluid that goes down about 2,900 kilometers. At that depth, temperatures get up to 3,500 degrees.
And then there's the core of the Earth, which is primarily composed of iron and nickel, down to 6,377 kilometers, the center of the Earth. Temperatures are near 5,500 degrees Celsius, which is extreme.
Volcanoes can appear through the crust of our planet because the mantle inside the Earth is not solid.
The mantle is fluid. It's kind of like solidified clay that we call a viscous fluid. The rigid plates move on top of that viscous fluid.
The mantle's rocks move very slowly and pull the Earth's crust from a few millimeters to a couple of centimeters every year. That's very little, yet it has enormous consequences on a geological timescale. That's how a single enormous continent gradually broke up. The various tectonic plates moved, broke up again, or collided with one another to shape the continents and oceans. What came to play in Auvergne is the movement of two of these plates, the African and European plates.
Africa has been moving northwards for a very long time, and in the most recent stage it closed the old ocean and it built the Alps. And the Alps, as they grew thicker and thicker, think of it as a boat. You've got a keel at the bottom, and that keel sank. And as it sank down, it drew the land apart next to it.
The plate got slimmer. It withdrew on itself and created a big fault. A large fault leads to collapse. In Clermont Ferrand, we can clearly see the collapse of this portion of the Earth's crust, the Limagne Basin, which is 30 to 35 kilometers wide.
Had the movement of these plates continued, Clermont Ferrand would have never existed.
If they had continued to diverge, there would have been two separate continents and an ocean would have been formed between them.
The plates' overlapping process stopped, but its effects were felt millions of years later with a slow rising of magma in the entire region.
When you have a tectonic plate starting to slim down, the Earth's mantle rises towards the surface, which melts the rocks. That's when magma is created, and it rises to the surface.
That rising first took place beneath the Limagne Graben, and then in the neighboring areas. When it came to the chaîne de Puys, the magma took advantage of some very old rifts.
We believe there were some mantle rocks that didn't come up exactly beneath the graben, but just next to it. That created the Mont d'Or stratovolcano and the chaîne de Puys.
A chain of volcanoes rich in diversity and a neighboring graben not covered by an ocean. That's what led to this location being classified as a UNESCO World Heritage Site.
This is a snapshot of a stage of the plate tectonics that can be seen in very few places on Earth. And here it's miniaturized, which is truly exceptional.
This extraordinary panorama was created over tens of millions of years. It may look definitively fixed, but what is really going on beneath the chaîne de Puys? Is there still magma that's ready to resurface at any time? To study these issues, this laboratory is one of the best equipped in the world. Found directly next to the Auvergne volcanoes in Clermont Ferrand, it's called the Magmas and Volcanoes Laboratory, or LVM. Some 150 researchers, engineers, and technicians of various nationalities work here. They conduct scientific analyses and field missions.
Field observations during eruptions, but also outside of eruptive periods to understand volcanoes are crucial. An on-site volcanologist will look for all kinds of information. Gravimetric, magnetic, electromagnetic, chemical, gas, or lava chemical composition, for example. All of that data will be used to feed the different models we develop.
With all of the information collected in the field, the volcanologists then create both computer models and scale models of volcanic phenomena. Such as this unique device, a 7-meter-long canal. The LMV volcanologists recreate volcano-triggered tsunamis. Tsunamis that can turn out to be incredibly dangerous. One of these particularly tragic eruptions went down in history. In Indonesia, between the islands of Sumatra and Java, the eruption of Krakatoa in the 19th century took the lives of 36,000 people.
In 1883, the summit of Krakatoa exploded. It generated an ash column that rose 50 kilometers up into the sky. The volcano eventually collapsed beneath its own weight. The eruption of Krakatoa was extremely powerful. because some said the noise of the explosion could even be heard in Australia, over 5,000 kilometers away. The eruption was accompanied by very large tsunamis, which had waves around 30 meters high, that whisked very large vessels and ships up to 3 kilometers inland.
In order to avoid such tragedies, the work of volcanologists is essential. Their mission also entails raising the alarm in case of danger. But even then, we don't always listen.
You can do any instrumentation, get any measurement, but if you don't communicate it to people, then it's all worthless. And we have many examples of that.
One of the most dramatic examples took place in Colombia, at the Nevado del Ruiz volcano. In 1985, scientists alerted the authorities weeks before the disaster. The city of Armero was destroyed, even though it could have been evacuated in hours.
There was a lack of communication between the scientists and the people who were at risk, which meant that there was no warning of an event that was anticipated.
In the afternoon, the ashes started to fall on Armero, and the people panicked. Then they tried to calm the people down. There were radio messages broadcast that evening saying, yes, the volcano is erupting, but there's no particular danger. It's also worth noting that the local population was not really prepared to evacuate quickly.
It was a small eruption, but it was erupted onto a glacier, which had fresh snow on it, and it was the hot rock melting the snow which caused a major flood of mud to run down the valleys.
It brought volcanic ash with it, but also large boulders. And the more the mud flood advanced, the more tree trunks and boulders it siphoned off. There was a wave of mud that descended on the city of Armero, which was located almost 50 kilometers from the volcano. It totally destroyed the city, claiming 23,000 lives, or 90% of the population, during that volcanic eruption.
Today, even though the places at greatest volcanic risk are primarily in Latin American and Asian countries, the chaîne de Puys, and above all, its subsoil, are being closely watched by scientists.
There are many mysteries that surround the Champs de Puys. That's what's getting people a little excited right now. We're finally starting to have the technological and geophysical means to figure out these questions.
Scientists in Nancy recently studied this topic. Geologists from CNRS hypothesized that a reservoir could exist between the Puy de Côme and the Grand Circuit, a mere dozen kilometers below the surface. According to them, it would be an impressively large reservoir of more than 6 cubic kilometers of magma. In comparison, the creation of the Puy de Côme only required 0.4 cubic kilometers of magma.
If there was a large reservoir that led to a series of eruptions 10,000 years ago, it's absolutely impossible that it has cooled in 10,000 years. There is so much thermal inertia in such a reservoir that it would take tens of thousands of years for it to cool completely.
The volcanoes of Auvergne are a hot topic among the scientific community, as evidenced by the study by the Nancy researchers that made a splash and sparked a debate.
The hypothesis that a chamber in some way unites the Puy de Côme and the Grand Circuit, passing via several volcanoes, doesn't hold up. It's not a defendable hypothesis.
Today, we think that if there were to be a new eruption, it will probably be due to a new injection of magma coming from the upper mantle, so something that's 30 to 40 kilometers deep, coming directly up to the surface.
And just what would happen if that magma came up from the depths, from the mantle beneath the Earth's crust? Would the region be beset with torrents of lava? Could it impact the urban areas closest to the chain, like Riom, Volvic, or Clermont Ferrand? This is the Puy Pariou, one of the most visited volcanoes in the chaîne de Puys. This type of volcano is labeled as Strombolian, meaning it discharges a lot of lava and is shaped like a cone with a crater at the summit.
Along the chaîne de Puys, what we see most often are Strombolian cones. You have very big lava flows that generally originated from Strombolian cones, or shall we say from Strombolian activity, and which cover a huge area, filling all the valleys. It's something very impressive.
The Puy de Côme, also a Strombolian volcano, spread its lava flows into the neighboring valley some 20 kilometers away. It actually has two craters slotted into each other because it underwent two successive eruptions. Yet both eruptions were caused by the same mechanism.
A fracture opened in the earth. Showers of incandescent lava were emitted, propelled by the gases, which then fell and accumulated around this conduit. That progressively built up a cone with a crater at the summit, which continued to expel lava until it ran dry.
Every minute or maybe every few seconds, a bubble of gas comes up through the lava and it bursts, and that throws material into the air.
After a few days, we had what we call a cinder cone, a crater at the summit with lava flows at the base.
These twins, with their partially collapsed craters, are also cinder cones. They're the youngest in the chaîne de Puys. Their lavas joined together to form a single flow and blocked off a river.
Lava flows from the Puy de la Vache and the Puy de las Olas spread over 15 kilometers to the Liman plain.
In some places, it could be hundreds of meters thick. These lava flows can create water dams, which in turn result in lakes, such as Lac de Dat.
If such flows occurred in the past, they could certainly happen again. The question is whether such flows would be confined to the dome plateaus or if they would spill into the nearby valleys.
If the lava flows stay on the plateau in wooded areas, apart from a few fires and some roads blocked off, they won't really bother too many people. It will be manageable. However, if the lava flows travel not to the west side of the plateau that's sparsely populated, but towards the east, towards Clermont Ferrand, now that's a significant urban area. There are around 140,000 inhabitants in the city of Clermont Ferrand, 350,000 if you include the greater area. That's a lot of people at risk.
Luckily, when it comes to Strombolian-type volcanoes, the eruptions tend to be localized, and the potential threat to the local population is relatively easy to discern.
Generally dramatic, but unless you're standing right next to it, you have nothing to worry about.
Even if people are rarely affected by this type of eruption, the physical damages can be consequential. To diminish their impact, volcanologists attempt to predict the trajectory of the lava flows. With tools they test on a very active volcano, Piton de la Fournaise, on Réunion Island.
There are regular eruptions, 2 on average per year for the past 40 years, and in 2019 there were 5. So we had 5 opportunities to model a lava flow. That means our digital model has been tested several times and is fairly well validated. We generally know where the lava will flow within a range of 200 to 300 meters. A lava flow can move relatively quickly in certain parts of the world, where the composition is such that the viscosity is extremely low. The flows are very fluid and can travel up to 12 kilometers per hour. But most lava flows move at only a couple meters per hour, which leaves a lot of time to evacuate. There are only 2 recent examples in 1977 and in 2002, at Mount Nyiragongo in the Democratic Republic of the Congo, where the eruptions were effusive and the lava flowed extremely quickly. Within hours, it had reached the city and people were not prepared. Some died, but the reason was because when lava touches a building, the walls collapse. It engulfed a gas station and it exploded.
Lava from this type of volcano reaches extremely hot temperatures.
Temperatures get up to 1,200 degrees Celsius for more basaltic lava flows, like the red lava of Piton de la Fournaise. Then there are other types of lava flows that are thicker and cooler and have temperatures closer to 900 or 1,000 degrees.
Even if they're not very fast-moving, these lava flows that range from 900 to 1,200 degrees are quasi-unstoppable.
In the past, several attempts were made to try and deviate or stop the lava flows, but very few of them were actually successful.
Near Mount Etna, they tried everything. They built barricades like dikes to try and deviate the lava elsewhere. They blew up the side of the lava flow with dynamite. They dropped large concrete blocks on top of it with helicopters, with various levels of success. It's great to deviate the lava, but you better divert it somewhere where there are no people. In the case of Champ de Puys, every valley where the lava could potentially be redirected leads to an inhabited area.
A team of international researchers is exploring how to react to lava flows east of the chain. Their objective is to test their digital models to see how quickly they could provide information to the local authorities. The study tested two scenarios. In the first, an eruption near the Petit Puy de Côme reached the center of Clermont Ferrand. In the second, the eruption took place at the Puy de la Grave Noire, a volcano on the edge of the Plateau de Dôme, just above the city. In that situation, almost all of Clermont Ferrand would be destroyed by lava.
Using models quickly after an eruption allows us to easily know which zones would be affected and which zones would be less affected. That would be very useful for alerting the authorities so they can make decisions about which zones should be evacuated or not, how to block roads, or to forbid access to certain areas.
Volcanologists are constantly developing simulation tools to predict future tragedies. But the authorities must be able to act on those warnings. And in some parts of the world, the leeway to act can be reduced because of urban development, particularly around highly active volcanoes.
Cities with 20,000 inhabitants at the start of the 20th century can now comprise 2 million people. And that's one of the big problems in Naples. Part of Naples has essentially a single road for evacuation in case Mount Vesuvius erupts. You can't evacuate 200,000 people from that area via a single road. The traffic jams will prevent people from fleeing.
Of course, Clermont Ferrand is not Naples. However, in the Auvergne region, there are other potential dangers besides lava flows. There's an even more dreadful scenario. Volcanoes that explode all of a sudden. These are known as Pompeii eruptions. But to what extent are they more of a threat? And why are they the most feared among volcanologists?
And that's the very dangerous type of eruption. And we do have that in the Chaîne de Puys. They're generally the ones to keep away from.
At 1,180 meters in altitude, this is the rocky needle of Puy-Chopin. Today, covered in pine trees, this volcano once exploded in the crater of an older edifice. When it erupted 10,000 years ago, the blast must have been one of the most impressive in the Chaîne de Puys, with an ash cloud that rose over 7 kilometers high.
There was a surge that carbonized everything on the Champ de Puys. And don't go thinking it remained local. Fragments were found in lakes as far as Switzerland.
In the Chaîne de Puys, there are fewer Pompeii volcanoes than there are Strombolian volcanoes, but they are more formidable.
They tend to look quite quiet. You don't see a lot of red things being thrown out, but then they tend to go off very quickly and explode.
The most emblematic of the Pompeii volcanoes is none other than the Puy de Côme. These volcanoes don't have a classic cone shape with a crater. They look a little misshapen, because the magma that created them is of a different nature.
A lava dome is formed by magma that cooled down in a magma chamber.
Little by little, the lava is enriched with gas. In fact, by the end, there could be only gas left. When this kind of lava shows up, it doesn't need external water to be incredibly explosive.
In this type of volcano, the magma that rises to the surface is extremely viscous. At some point, it can no longer flow along the surface. It accumulates and shapes a dome that grows like a rising bread dough. The pressure continues to rise underneath, eventually causing an enormous explosion.
That's what triggers the eruption, which can be an upwards plinian eruption, or it can explode laterally.
If the volcano itself explodes, there can be an ash plume. The ashes can be carried very far, dozens or even hundreds of kilometers away. Here we have a lot of westerly winds, so you can imagine that the entire region east of Auvergne-Rhône-Alpes could be affected.
These are the kind of rocks that can be launched by a volcano. Some of these volcanic bombs can be as big as a house. But other phenomena can be even more dangerous when the explosion takes place sideways.
When it's lateral, it's called a nuée ardente, or pyroclastic flow.
It's a very frightening thing to see. You see a small cloud appear at the top of the volcano, and it goes up, but it also comes towards you. It seems very slow at first, and then it comes quicker and quicker and quicker.
It's a mix of burning gas, hot ash, and rock fragments that flows downslope at considerable speeds, up to 300 or 350 kilometers an hour. It's also incredibly hot, like 300 to 350 degrees Celsius. Everything in its path is completely destroyed.
It's no coincidence that pyroclastic flows are behind many of the deadliest eruptions on record. For example, when Mount Vesuvius erupted in Italy.
The eruption of Mount Vesuvius in 79 AD is the world's most famous natural disaster and is inseparable from the history of Pompeii. The first phase of the eruption was the formation of an ash plume. Then, the eruption column collapsed, generating pyroclastic flows. We've counted up to 6 pyroclastic flows. It was the 4th one that destroyed Pompeii, and Herculaneum, which was located much closer to the volcano, was buried under 20 meters of volcanic deposits.
The same tragic scenario took place at Mount Pelée in Martinique. The city of Saint-Pierre has since been rebuilt, but in 1902 it went through a deadly tragedy. And yet, the Mount Pelée volcano had given off concerning warning signs weeks before it erupted.
The authorities didn't want to evacuate Saint-Pierre during the elections. They said there was no danger and that the elections would still be held the following weekend. But there was no following weekend for the 28,000 people who lived in Saint-Pierre. They were completely incinerated by Mount Pelée's pyroclastic flow.
In the Chaîne de Puys, the domes, these explosive volcanoes, are primarily found in the center of the chain. In other words, right next door to Clermont Ferrand and its 143,000 inhabitants.
That central part of the Chaîne de Puys is very close to the city. Within a range of 5 to 10 kilometers, a lot of people could be affected.
New domes could be even more explosive, as the magma has likely evolved over time. Luckily, most scientists believe that the remaining intermediate magma chambers are rather small in size.
Indeed, as time passes, it gets more viscous. It could rise to the surface, but there may not be enough magma to create something like the Puy de Côme that could be genuinely dangerous. But we still need to monitor it.
How does one keep an eye on these potential bombs? With what tools? Could an eruption take place in the Chaîne de Puys that completely catches scientists off guard? Every year, the planet experiences around 60 eruptions, although most of them happen under the oceans. There are too many volcanoes on the surface for all of them to be under constant surveillance.
There are 1,670 active volcanoes on the surface of the Earth. We don't have that many observatories.
So what do? We focus on the most dangerous.
Some volcanoes have entire organizations studying them. Volcanic observatories are assigned to monitor them, like the French overseas volcanoes on Reunion Island in the West Indies.
There is no monitoring laboratory dedicated to the Chaîne de Puys. But like every other volcanic zone on the planet, the region is scanned from the sky.
Technology has evolved considerably, and we can now monitor volcanoes from a distance.
We have satellite systems that are used with increasing frequency. For example, radar interferometry, which provides highly precise data on the level of deformation of volcanoes.
Satellites can spot when a volcano is deforming before an eruption. They can monitor the evolution of volcanic crises and are increasingly efficient, especially for hard-to-access areas.
There's one named HotVolc, which gathers quantitative information throughout an eruption. Things like the amount of gas, the density of ash plumes, or the lava flow rate. All of that data is absolutely essential to the digital models. When the Icelandic eruption of Eyjafjallajökull took place in 2010, the HotVolc system was key. The satellite monitoring system of infrared thermal imaging allowed us to follow the plume in what is a very topographically complex region. That plume led to complete cancellation of flights between Europe and the United States.
To avoid such situations, volcanologists scrutinize their monitoring tools. Whether for the Chaîne de Puys or the rest of the planet, they are on the lookout for familiar warning signs. But sometimes volcanoes escape their watchful eye.
The first thing that tends to happen is the ground starts shaking. And that may happen months or even years before anything happens. You will get gas probably coming out. So there tend to be a sequence of events that lead closer and closer to the eruption. So normally you get a lot of time, but sometimes there's no warning.
That happened in Chaitén in Chile in 2008. Chaitén had been dormant for 9,000 years, but 24 hours went by between the first underground earthquakes and the first explosion of the old dome, which was polarized during the eruption.
Most scientists believe this kind of surprise would be highly unlikely in the Chaîne de Puys. The local volcanoes have only known a single eruption, and their conduits are all completely plugged, meaning magma wouldn't be able to rise up unnoticed.
In the Chaîne de Puys, if the volcanic system reactivates, first we'd have molten magma at the base of the crust, at a depth of around 30 kilometers. Then the magma would slowly rise up and have to forge a path towards the surface. That's when fracturing would cause earthquakes, which would first be noticed underground and then closer towards the surface.
We would most likely be able to see that something was happening a couple months or a couple of weeks before the magma even got to the surface.
Seismicity is the precursor that would allow us to put a denser monitoring system in place. At the same time, of course, the satellites would continue to orbit, capturing images of the Chaîne de Puys.
Could we ever see scientists from the Magmas and Volcanoes Laboratory set up an observatory in the Chaîne de Puys after an earthquake warning? From a theoretical standpoint, it's not impossible.
The last eruption was 8,600 years ago. In geological terms, that's not even yesterday. That's today at lunch. So it's completely possible a volcano could rear its head at any moment.
Unaware of the potential threat, the region's inhabitants have always enjoyed the volcano's benefits. Even in ancient times, the Romans used volcanic rock, trachyte, to build the Temple of Mercury on top of the Puy de Côme.
Trachyte is the lightest colored rock in the chaîne de Puys. It's easy to carve and to transport because it's relatively light. A quarry was actually opened at the foot of the Puy de Côme, specifically to build the temple. There was nothing there before.
Volcanic rock extracted from volvic mines was also used in the Middle Ages. It was notably used to build several churches, in particular, one that's nicknamed the Black Cathedral, the Cathedral of Clermont Ferrand.
In the 19th century, they built the center of Clermont Ferrand with this black lava, which looked a bit somber to some. Same thing for Riom, which is magnificent and also built entirely of lava rock. That's no longer done, but volcanic rock continues to be exploited.
Notably in this kind of quarry, where the volcanic rock is extracted before it is crushed. The end result is called pozzolana.
Pozzolana is lava fragments that were projected during an eruption, many small fragments of various sizes.
Pozzolana is a relatively sought-after construction material. You can make filters with it or mix it with concrete. It's also used in farming. It has many uses.
Despite this material's interest, the last two quarries in the chaîne de Puys will close before 2030 to comply with UNESCO World Heritage Site requirements.
In 2018, the entire Chaîne de Puys and the Le Mans Fault were classified as a UNESCO World Heritage Site. That's an incredible international recognition, and it's the only natural site in all of mainland France that's on the UNESCO list.
A unique site that could see a new volcano appear at any moment, including next to the plateau of the ancient Puys. Luckily, the probability of a surprise eruption is extremely low. It won't take a possible reactivation for scientists to continue exploring the chaîne de Puys. They seek to understand its history and also to tap into one of its greatest riches, its water reserves. They hope it remains peaceful as long as possible. A picture-perfect postcard and a testament to a fascinating geological past.